All right, today we're going to be talking about Chapter 3 in Fire in California's Ecosystems. It's all about the fire weather principles, so it's maybe my favorite chapter of the textbook, being a broadcast meteorologist. What we're going to do is talk about the four main components of fire weather: temperature, moisture, wind, and stability. And just like the last couple of weeks, I summarized the whole chapter in a 1-minute video, and then what we'll do afterwards is go through it line by line, really just dive in and learn more about wildfire together. The fire behavior triangle consists of fuel, weather, and topography, with weather being the most dynamic element due to the impact that sudden changes in temperature, moisture, wind, and stability can have on wildfire. Warmer temperatures bring fuels closer to their ignition point, but the main role of temperature is in how it influences the other components. For example, warmer air can hold more moisture, so as temperature goes up, relative humidity goes down. Drier air pulls more moisture out of the fuels, making it easier for fires to start and spread. Additionally, differences in temperature across an area are the primary cause of wind, which has major impacts on fire behavior. Wind supplies more oxygen to the fire, transports heat, and can even toss burning embers ahead of the major blaze to create spot fires. Stability can be a bit harder to grasp, but think of it like a chimney. An unstable atmosphere is like having the damper open. With more airflow, the fire becomes more active. The first sentence of the video is kind of an introduction to the chapter, and it lays the foundation, so let's go through it. The fire behavior triangle consists of fuel, weather, and topography, with weather being the most dynamic element due to the impact that sudden changes in temperature, moisture, wind, and stability can have on wildfire. So the two main aspects to focus on here are the fire behavior triangle and then the fact that weather is dynamic. So fire behavior triangle, those are the three components that are going to have the largest impact on fire behavior. It's fuel, weather, and topography. Topography, think fire goes faster uphill. With fuel, think if your fuels are more continuous, if you have more of them, if they're drier, then you're going to have more active fire behavior. And then weather, think hot, dry, windy. And I go on to describe weather as dynamic due to sudden changes. So what I'm touching on there is that your weather changes at a much smaller time scale than the other components. For example, topography, it might take thousands of years for a mountain range to be lifted up, but then you're going to have faster fire growth up that slope than if it was a flat ground. You're also maybe going to have forests on one side, desert on the other, so that'll impact your fire behavior, obviously, because you'll have more fuel on the forest side to sustain more fire, but that's going to change over very long time scales. So when I'm forecasting wildfire, I'm not going to look at how the topography is changing throughout the day. You may look at how the fuels change because your lighter fuels will respond to moisture, sometimes on an hourly time scale, but your fuels also change on a much longer time scale as well, sometimes years, decades. You have different fuel distributions based on if you have maybe a warming trend or a cooling trend in your climate, based on how the moisture is changing in the atmosphere, if you have drought, those kind of aspects. So fuel is kind of that middle ground. And then weather, probably don't need to explain this to you, but weather can sometimes change by the minute. It could be sunny and warm 1 second, then a thunderstorm comes through, all of a sudden it's super windy, you have some lightning, maybe it pushes the fire in erratic directions. So that can change very quickly. So that's what I mean by dynamic. And then within weather, the one we're going to be focusing on today, because it is that dynamic aspect, big part of wildfire forecasting is knowing what the weather conditions are going to do. And the four variables that you're going to look at the most closely are going to be temperature, moisture, wind, and stability. Let's get into temperature first. Warmer temperatures bring fuels closer to their ignition point, but the main role of temperature is in how it influences the other components. The main point I'm making here is that temperature does have direct influences on wildfire. For example, it brings fuels closer to their ignition point. So if it's hotter out, then it requires less energy to bring those plants up to the temperature where you can have combustion. But the major impact that temperature has is actually indirect, and it's how it influences things like wind, moisture, and stability. So it maybe is important to do a little background on what is going to lead to warmer temperatures versus cooler, because obviously as things get hotter, that's going to lead to worse wildfire conditions. So one aspect is what time of the year it is. During summer, the sunlight coming in is at a much more direct angle. That's going to make things hotter. You also have more hours in a day. So the more hours you have to pick up sunlight, the hotter it's going to be. That ties into kind of cloud cover as well. If it's cloudier or you have a lot of smoke, not as much sunlight can come in. So it's going to be cooler on cloudy days, warmer on sunny days. That's pretty intuitive. Maybe what's less intuitive is actually cloudy nights will be warmer because it helps trap in some of the heat. And then another one that's not exactly intuitive is it depends on what direction your slopes will face based on how much heat you'll be able to pick up. So basically, north-facing slopes have less direct sunlight than your south-facing slopes, at least in the northern hemisphere. So your south-facing slopes are typically going to be warmer and drier, and then that has impacts on wildfire because, well, drier fuels, it's easier for fires to start and spread. Now, another one is that temperature typically gets cooler as you go up in elevation. So you think your mountains are usually cooler than your valleys. Reason for that, your valleys literally just have more atmosphere and a weighing down on them. The pressure is going to be higher. The particles are going to be bumping into each other more, and that's going to make your temperatures hotter. Then the kind of exception to the rule is along the California coast where, let's say, Santa Cruz Mountains, you would think, oh, higher elevation, that should be cooler than, let's say, Santa Cruz. But Santa Cruz is actually cooler in summer because we have that marine influence because it's close to the coast. So there's lots of little nuances there, and it's all these nuances in how hot things get that are going to impact your fuels, how much moisture you have, what direction the winds go, and that's kind of the main thing we're talking about throughout the rest of the video. For example, warmer air can hold more moisture, so as temperature goes up, relative humidity goes down. Drier air pulls more moisture out of the fuels, making it easier for fires to start and spread. A good place to start might be just describing relative humidity. You've probably heard that term. It's very important for wildfire forecasting. You could think of relative humidity as how much moisture is in the air versus how much moisture can the air hold. And a big part of how much moisture can the air hold is the temperature. So as temperatures go up, the air can hold more moisture. So as temperature goes up, your relative humidity is going to go down. The other way to change that would be to bring in more moisture, which is going to make your relative humidity go up, or to bring in drier air, like the Santa Anas do in Southern California, and then that's going to increase your fire activity. Now, one thing you probably intuitively know is that temperature goes up in the afternoons, down at night. So the same thing, or actually the reverse, is going to happen to your relative humidity. During the afternoons, it's going to go down, and then at night, it's going to go up. So that's part of the reason we see fire activity peak in the afternoon hours, and then it usually calms down overnight. Now with relative humidity, you might wonder, okay, why does that matter? How much moisture is in the air versus how much the air can hold? Well, it all has to do with the balance between the air and your fuels. So in your fuels, there's moisture. In the air, there's moisture. And you can almost think of it as trying to create some sort of equilibrium between the two. And how quickly it can do that is going to depend on how large your fuels are. So in your very fine fuels, it's going to try to balance itself out with the moisture in the atmosphere. So if your atmosphere is maybe getting too wordy, so I'll try to simplify it. If your atmosphere is drier than your fuels, it's going to pull some of that moisture out of your fuels. But if your fuels are drier than the atmosphere, then it's actually going to pull some of the moisture out of the atmosphere and bring it into your fuels. So it's trying to basically equalize itself. And the smaller the fuels are, the faster that's going to happen. Don't want to get too technical here, but it has to do with the surface area to volume ratio. So if more of your fuel is surface area, it's going to be able to interact with the environment more around it. So again, trying to simplify it, grasses are going to respond to, let's say, dry air very quickly. They're going to dry out in maybe an hour, whereas fuels the size of, I don't know, like a branch, that might take weeks to respond to the environment. So it might only get more moist during winter and then drier during summer on very long time scales. So, and then simplifying it again, why is that important? Well, we'll just use an analogy. If you've ever done a campfire and you have a moist log or a dry log, it's obviously much harder to start the fire with the moist log. And then with the dry log, you not only start the fire faster, but then it's going to burn a lot hotter once you do have that fire going. It's going to burn faster as well. So that's why moisture is mostly important in terms of relative humidity. The other aspect of moisture is going to be rainfall. So most of our rain in California falls in winter. That's part of the reason that we don't have very active fire behavior during winter, because there's a lot of moisture in the fuels. During summer, we have a Mediterranean climate, so at the warmest part of the year, it's also the driest part of the year. And that's a big part of the reason that wildfire is natural to California. So during summer, the fuels are going to be very dry. That's going to lead to much more active fire behavior. Now, one thing I should put as a little caveat there, you think, okay, in a very rainy winter, that's going to bring more moisture into your fuels, so then fire behavior is going to be less. True, but you've probably also heard the argument of, if you pick up more rain, then you have more fuel, and then that's going to make wildfire worse. Well, it kind of depends on what fuels you're talking about. It is true for grasses that if you have more rain, you are going to have more grass, and then those respond to the atmosphere very quickly. So you get into summer, those are going to dry out, and then you do end up getting more grass fires after a rainy winter. But in those larger fuels, it's not going to change the distribution that much. They've maybe been there for decades. You're not going to have whole trees popping up just because you had one rainy winter. So that's going to respond on a much larger time scale to, let's say, droughts. So if you have very dry years in a row, then your forests dry out, and then you have a lot of fire activity up there. So it's kind of the brief overview of why moisture is important. Now let's look at wind. Additionally, differences in temperature across an area are the primary cause of wind, which has major impacts on fire behavior. Wind supplies more oxygen to the fire, transports heat, and can even toss burning embers ahead of the major blaze to create spot fires. So I start off this section once again talking about the influence that temperature has on wind. So I say the difference in temperature across an area is the primary cause of wind. I think the best way to think about this is a valley and a hillside. During the afternoon, the hillside is going to heat up more or faster than the valley. So then you get rising air on your hillside, which has to be replaced by air from somewhere else. So you get air rushing up from the valley up the hillside. So it's a big part of the reason that some of your worst fire activity is going to be in the afternoons on slopes, because you not only have the aspect of topography, where fire likes to go uphill because it's able to preheat the fuels, but it's also, you have winds rushing uphill, pushing that fire forward. So the opposite, interestingly, happens at night. Your hillsides cool off faster, and then that cold air sinks into the valley below. So then that actually leads to winds going down, but usually those winds aren't as strong as your afternoon breeze. So that's the aspect of how it connects with temperature and differences in temperature. But now I just want to focus on those main ways that wind impacts fire. The first one that I mentioned is it supplies more oxygen to the fire. Basically, for combustion to occur, you need heat, oxygen, and fuel. I believe for combustion, it needs to be 16% or higher oxygen. It's getting into the chemistry a bit there. So instead, just think about a campfire. When you're starting the fire and you have a little spark going, maybe there's a little smoke, instinctively, almost everyone will start to blow on the fire. You see this in the show Survivor sometimes. And then all of a sudden, that little spark turns into a flame and they got the fire going. And what they're doing when they're blowing on the fire is they're providing more oxygen to it. So what wind does is it pushes more oxygen into the fire, and it's basically like you blowing on a campfire, but on a much larger scale. Now the next one I talk about is it transports heat. And this is similar to what I just mentioned about topography, about flame tilting is able to heat up the fuels ahead on that uphill slope, so then that leads to faster fire spread uphill. Well, even if your land is flat and you have a fire, if it's a calm day, most of that heat's just going to be going straight up because heat rises. But if it's a windy day, think what happens. It takes some of that heat from the fire and it's going to push it ahead of the fire. Now when it does that, it's going to heat up the fuels ahead of the fire. As they heat up, they dry out. So then by the time the fire gets there, it doesn't need to waste any of its energy to dry out the vegetation. That vegetation is just ready to combust, so then it bursts into flames, and then the fire is able to just go a lot faster than it otherwise would be. The other thing that it's doing there is also tilting the flames over. So then you can imagine how that would heat up the vegetation in front of the fire faster as well. That reminds me, didn't mention it, but your wind is usually going to determine the direction of your fire spread, and it's in large part because of that, because it's heating up the vegetation, so then that's going to lead to fastest spread in the same direction as your wind. Now, another reason that wind usually determines your fire spread is it can also start spot fires. That's the last thing that I mentioned here. This is one of the most important things I've seen in wildfire forecasting. I believe it was the Dixie Fire, where they'd spent days creating containment lines around the northern edge of the fire. They'd done a great job. And then we had a really strong wind event where winds were coming from the south, and it picked up burning embers, tossed them, I think, over a mile past the containment lines. And then those little burning embers went into the dry fuels, started their own little fires, and the fire took off 15 miles in one day, which was not good on that fire, because then it just kept going for weeks after that when it looked like they almost had it contained. And that's something we often see, and is something that's very important. And you can imagine how frustrating that'll be for firefighters, where you can have it contained, creates little spot fires, then you have rapid growth. So that's kind of the main ways that wind influences wildfire. There are some novelty ways as well. One is if a thunderstorm comes through, you can have indrafts and then downdrafts. So that'll rapidly change the direction that your wind is coming from, which can rapidly change the direction that the fire is going. So that can lead to some dangerous situations. And thunderstorms are kind of a wild card, because sometimes you have that aspect where it's erratic winds or lightning starting new fires, but then sometimes they bring rain and actually reduce your fire activity. So with thunderstorms, it really just depends on the individual event, whether it's going to be good or bad for wildfire. Now, you can also see changes in wind direction if a cold front comes through. We usually don't see that all that much in California during summer, though. What we do see a lot more is as we get kind of late summer and into fall, we have what you call fern winds. Hopefully I'm pronouncing that right. Instead, I'll just talk about examples of fern winds. In Southern California, you might refer to them as Santa Anas. In Santa Barbara, sundowners. In Northern California, Diablo winds. And this is where you get hot, dry air coming down the leeward side of a mountain. So as the air descends, it's going to compress, it gets hotter, and then it's dry. That can dry out your fuels. When that air gets funneled through canyons, like we often see with the Santa Anas, then that can lead to 60 to 80 mile per hour gusts that can just rapidly spread a fire. So some of the worst fires that we see are because of those kind of wind events. And the reason that they're called sundowners in Santa Barbara, it actually ties in with what I was saying earlier about how during the afternoon you have winds that go uphill, and then at night you have winds that go downhill. So if these fern wind events are winds rushing down the leeward side, during the afternoon, that's going to get canceled out by that afternoon uphill breeze, whereas at nighttime it's actually going to pair up with that downslope breeze that you have because of the cooling hillsides going down into the valleys. So the reason it's called sundowners in Santa Barbara is these events usually happen after sundown or overnight, which makes them very dangerous events because it's when a lot of people might be sleeping, not paying attention to the fire activity, or you let your guard down because you think, oh, fire's not going to be that bad at night. But in some cases, like in Santa Barbara, the temperature will actually go up by 15 degrees when it should be going down. Air gets dry, dries out the fuels, bad wildfire. Maybe spend enough time on that though, so let's now move on to the last component, which is stability. Stability can be a bit harder to grasp, but think of it like a chimney. An unstable atmosphere is like having the damper open. With more airflow, the fire becomes more active. Stability can kind of be one of those terms where people's eyes sort of gloss over because it just sounds a bit too sciencey, but just think of it like ventilation in the air or vertical motion in the atmosphere, how much your air is moving around or how easily air can rise. So with that, I think a good example would be a very stable atmosphere. Think of the California coast. We have this very cold, moist air from the ocean that'll go over our coastal cities. So then we have cold air actually below warmer air. That's called an inversion because usually your air gets colder as you go up because of a decrease in pressure. But because we have cold air under warm air, that cold air is more dense, and then it's almost like salad dressing where it separates where the more dense liquid is at the bottom, and then it just settles there. And there's not going to be a lot of movement. That's like the California coast when that marine air moves in. Now the opposite of that is going to be like, let's say your valley or your hillsides during the afternoon hours. That's where your surface is heating up a bunch. So then all of a sudden you get this very hot air on the surface, which is now less dense than the air around it, and it's going to want to rise up. Now what is going to determine whether it does rise is a little technical. It gets into environmental lapse rates and all that kind of stuff, but basically what matters is that parcel of air going to cool faster or slower than the environment around it as it rises? So if that parcel is going to stay warmer than the environment around it, then it's going to stay less dense, and then it's going to keep rising. And then what's important here is if that parcel of air is saturated, like what you might see in a cumulus cloud, then it is much easier for it to stay warmer because condensation releases heat. I think an easy way to think about that is evaporation requires heat. You have to have your stove on to boil your water, and then it burns off. Whereas the opposite happens with condensation. When you have water vapor turning into liquid, it actually releases some heat. So that's going to keep your air parcel warmer, and then that's going to lead to rising motion. That's why cumulus clouds can sometimes grow so tall, as you've seen. Now, how does this tie back into wildfire? Basically, the more vertical motion you have, the more unstable your atmosphere, like during the afternoon hours when you have a lot of surface heating, the more air is going to be moving around. The more air that's moving around ties into that wind component we were talking about, where it can push in more oxygen, it can push in some drier air, like we were talking about with the fern winds, and then that's going to impact your fuels. So this really ties into the main point that I want to make to conclude this video is I've talked about each of these somewhat separately. We've tied temperature in with a number of them, but really all of these different factors are interconnected. So it's hard to say, oh, this one's the most important or that one's the most important, because they all influence each other in different ways. And on some fires, maybe wind was the biggest factor, whereas on some fires, maybe the fact that the fuels were really dry is the most important factor. And maybe on another fire, weather actually wasn't that important and it had more to do with topography. So weather and its influence on wildfire is very interesting. That's why I just spent a lot of time talking about it. But it really is interconnected with the whole fire behavior triangle: fuel, weather, and topography. So I know we're going to be learning a lot more about that as I continue to go through this book. So I'll try to take what I learn, try to communicate it to all of you as well as I can. And I'm excited to see what we'll learn next. Thanks for watching.